Hi grade 9. So today is lesson 8.4 and 8.5, which is about surface area and volume of cones and pyramids. So there's a handout on Teams that you should print and fill in as you watch this video. So at the top of your handout there's a chart, and it has a few columns, and there's a bunch of shapes in there. We're going to talk about how to find the surface area and volume of those shapes. So the first section says prism. And a prism is a shape that has a uniform depth from end to end. So that means it has the same depth from one end to the other. It's a 3D shape, and it doesn't get skinnier on the end. It stays the same width the whole way across. So you can have a hexagonal prism. That just means that the base is a hexagon. So it has 6 sides, or a cube, which each side is the same. A rectangular prism, it's the shape of a rectangle. Triangular is a triangle or a cylinder. So to find the surface area of a prism, you're going to use the net to find the sides. So the net is when we would open up this prism so that it was a 2D structure. So, for example, if I have a cube and I lay it out flat, it will look like this. Right? And that's called the net. So to find the surface area, we need to find the combined area of all the 2D shapes in the net. So we find the area of each one of these shapes, add them together, and that's the surface area. So the total surface area of a prism equals the area of side 1 plus the area of side 2 plus the area of side 3, and so on until we've taken the area of all the sides and added them together. And that's the total surface area. To find the volume of a prism, we would do capital B times H, where capital B is the area of the base. All right, so don't confuse this with the lowercase b, which just represents base, but the capital B represents the area of the base. So area of the base times the height, and that's the volume of a prism. The next shape is the cone. So the cone is a 3D shape which tapers from a circular base to an apex or a tip. So this is the apex. We have the radius, we have the height, and then this slant here, that's called the slant height, and we represent that with a capital L. Okay, if you want to know how they come up with all of this information for surface area and volume, you can look on page 453 in your textbook. All right, so to find the surface area of a cone, there's a picture of the net there, which is the circle, which is the bottom, and then also the sides, if they were unfolded, would look like that piece of pie sort of thing. All right, so in here, this is the radius, and this is the slant height. So the surface area is pi r squared plus pi r L, which is slant height. So sometimes that L will be missing, and you'll have to find it, and I'll show you how to do that shortly. And then the volume of a cone is 1/3 pi r squared height. So 1/3 times pi times the radius squared times the height. And the last shape is a pyramid. And you can have different types of pyramids. So the base can be different. You could have a square base, a triangular base, a hexagon base. So the base is really what's going to make the difference, because it also determines how many sides are going to be on the pyramid. But the definition of a pyramid is a 3D shape which tapers from its base to its apex or the tip as well, same as the cone. So the surface area of a pyramid, you need to add the area of the base and the area of all the faces. So another way to write that would be area of the base plus area of side 1 plus area of side 2, and so on until you've done all the sides. And then the volume of a pyramid is 1/3 uppercase B H. So again, the B here is the area of the base. So the volume is 1/3 times the area of the base times the height. Okay, so let's practice some of this. So number 1, find the surface area of a cone with a radius of 3 centimeters and a height of 12 centimeters. So it's always best to start with a diagram if they don't give you one. So just a little sketch, I'll draw a cone. The radius is 3 centimeters. And the height is 12. So let's go back and review what the formula is for the surface area of a cone. So the surface area of a cone equals pi r squared plus pi rl. So I know r and I know pi, but I need to find l in order to fill in this equation. So if I take from this cone, this triangle here, I can find the length of L using the Pythagorean theorem, which you learned in the last lesson. So in this case, L is in the place of C because it's opposite the 90-degree angle. So I have 3 squared plus 12 squared equals L squared. 3 squared is 9. 12 squared is 144. 9 and 144 is 153. Take the square root of both sides. And the square root of 153 is 12.4 approximately. Alright, so now I have the slant length. L is 12.4. So now I can plug that into the equation. So I have pi r squared, radius is 3, plus pi r, which is 3, and L, the slant length, which is 12.4. 3 squared is 9, and then 3 times 12.4 is 37.12. Pi times 9 is 28.3. Pi times 37.12 is 116.6. Add those together, and that's 144.9 centimeters squared. So the surface area of this cone would be 144.9 centimeters squared. When you're typing this into your calculator, you should use the pi button. You might have to hit shift before you're able to get pi. If you don't have that option or you can't find it, you can also just use 3.14 for pi. Okay, on to the second sheet. Number 2. Find the surface area of a square-based prism with a height from the center to the base of the apex. The center of the base to the apex. The height is 12 centimeters and the base has 10 centimeter sides. Okay, so this is a square pyramid. 10 centimeter sides on the bottom, and the height to the middle is 12. Okay, so the surface area of a pyramid is the area of the base plus the area of the faces. So in this case, the area of the base is a square. So that would be area of the base plus, since it's a square, it has 4 sides, meaning there's going to be 4 triangles that are the faces. So the area of 4 triangles. Okay, now, one of the sides looks like this, right? And inside of the triangle there, I know that that's 12, and the length to there is 5 because it's halfway across. this triangle here. The base here. So that would be 5. And I need to find the height of these side triangles. So using that information, if the base is 5, that length is 12, and I need to find this length here, which we're going to call L for slant height, I can use the Pythagorean theorem again to find that height of the triangle on the face. So now I have 5 squared plus 12 squared equals L squared. So 25 plus 144 equals L squared. That's 169 equals L squared. Take the square root of both sides, and L equals 13. Right, so now that I have, if this is one of my faces and I'm looking straight on now, the height of that is 13, and the base of the whole thing, so that's one of these sides, is 10. Now I can find the area of that triangle and then times it by 4 for this area of 4 triangles. So the area of one triangle is base times height divided by 2, where the base now is 10, the height is 13. Divide that by 2, so it's 130 divided by 2 equals 65. And then the area of the square base is just 10 by 10, so that's 100. So now the total equals area of the base, 100, plus the area of 4 triangles, so 4 times 65. So that's 100 plus 4 times 65 is 260. So total surface area is 360 centimeters squared. Number 3. Find the volume of the cup. The cup is 9 centimeters tall, and had the cone not been truncated or cut, it would have been 18 centimeters. So this is the information we're given. So the orange is the cup. This whole distance here is 8.8. And the complete height, if it wasn't cut off, was 18. But the cup itself is 9. All right, so in order to find the volume of the cup, I'm going to need to find the volume of the large cone, the whole green one, minus the volume of this small cone down here. And that will leave me with just the orange left. So the volume of a cone, we'll start with the large one, equals 1/3 pi r squared height. The radius now, they give me 8.8, but that goes across the whole way, so that's the diameter. So the radius equals 8.8 divided by 2, which is 4.4. And the height is 18. You can, 4.4 squared. You can punch that into your calculator all at once, or you can do step by step. I'll just do one step at a time. So 4.4 squared is 19.36. 19.36 times 18 is 348.48. And then multiply all of that together is 364.93. So that's the volume of the large cone. Now I need to find the volume of the small cone and then subtract it. The only problem is I don't know the radius of the small yellow cone down here. Right? They don't give me that information. So I need to find it. So I'm just going to redraw it over here. This is the small cone. The height of this cone is also 9 because my tall cone was 18, My cup is 9. 18 minus 9 is 9. I do not know the radius, so I'm going to call it x. And then I need to find this length here. So in order to do that, I can find the slant height on this large cone, and then this small length over here will be half the slant height, or half L. So first I'm going to find L on the big cone. So this is my big cone. The radius was 4.4, and the height was 9. So, sorry, the height was 18. So if I form this into a little triangle here, then I can use the Pythagorean theorem, a squared plus b squared equals c squared, where c here is L, or my slant height. So that's 4.4 squared plus 18 squared equals L squared. 4.4 squared is 19.36. 18 squared is 324. Add those together, 343.36. Take the square root of both sides, and L equals 18.53. Okay, so now I have L, or the slant length. I'll write it over here. L equals 18.53. Now, going back to the small cone over here, half of L then would be 18.53 divided by 2, which is 9.265. All right, so now that I have that, I'm actually able to find the radius, because here I have another little right triangle where L, or the slant length, the half the slant length here, is the C value because it's across from the right angle. 9 would be B and X would be A. So now A squared plus B squared equals C squared. I'm just going to erase the volume of the large one so I can keep these little diagrams here. Now I have A squared plus B squared equals C squared, so I'm working on this, where A squared is X squared plus B squared was 9, and C squared is 9.265 squared. So X squared plus 81 equals 9.265 squared is 85.84. So X squared equals 85.84 minus 81. I just subtracted 81 from both sides. X squared equals 4.84. Take the square root of both sides, and X equals 2.2. So now the radius here is 2.2. So now that I have the radius, I can find the volume of that small cone, and then I'll be able to subtract it from the volume of the large cone. So this is my small cone. My radius is 2.2, and the height was 9. Now, the volume of the small cone, so volume of a cone is 1/3 pi r squared height. So 1/3 pi radius is 2.2 squared, and the height is 9. 1/3 pi 2.2 squared times 9 is 43.56. Multiply that all together, 45.62. So now the volume of the cup equals the volume of the large cone minus the volume of the small cone. The volume of the large cone was 364.93, and the volume of the small cone was 45.62. Subtract, and you end up with 319.31 centimeters cubed. Volume is always cubed. Therefore, the volume, of the cup is 319.31 centimeters cubed. All right, hopefully that wasn't too confusing for you. Let me know if you have any questions, and please rewatch the video if you need to. And good luck on your homework. And like I said, let me know if you have any questions, and I'll be happy to help.